Hi, I'm Saif. We're Team 1, and I'm doing the multisim part.
Hi, I'm Winter Calkins, and I'm doing the old school bench method.
Hey, I'm Greg. This is Team 1, and I'm doing the old school method.
Alright, today we're going to show you how to create an AC circuit and take measurements in multisim. First, what we want to do is create a title block, so we go up to Place, Title Block, Default, and we'll place the title block. Then we're going to double click. In our description, we'll put AC Team 1, because that's our team. Team 1 circuit designed by, and then we'll put whoever's name. This is mine. Next, we're going to place our components. So we go place component, right click, place component. And then what we're going to want to do is go basic, resistor, and we're going to put in our 100 kilo ohm resistor. Place that there. Next, we'll do our 56 kilo ohm resistor. And place that there. But first, what we're going to want to do is rotate this 90 degrees clockwise, and then we can go add in the rest of our components, which are under sources, power sources, AC power. Then we have to put in our ground too. And then we need to go over to indicators, voltmeter vertical. And we need to do this for voltage source and R2. We can X that out, and then we could add in our oscilloscope. So we go to the right hand corner of the screen, press oscilloscope, put that in there. And first we need to do some fine tuning. So we double click the voltmeters, set that to AC, which is very important because we're measuring AC. And we need to do that for both, so set them both to AC. And next we change our voltage source to 10 volts RMS. And we change our frequency to 2 kilohertz. And then we connect it all. So V1 goes to R1, R1 goes to R2, R2 to ground, V1 to ground, and then we can connect up our voltmeters. U1 goes to the voltage source, U2 goes to across R2. Then the oscilloscope channel A positive goes to the positive side of our circuit. Channel A negative goes to the negative side, obviously. Channel B positive goes to the top part of R1, R2. Channel B negative goes to the negative side of our circuit. First, we're going to want to do net color, change the negative side to black. And for channel B positive, we're going to want to change the segment color to blue. And that's our circuit. Then we're going to want to play the circuit, make sure all our measurements come out, and the oscilloscope gets enough time to create a good measurement. We can stop the circuit, double click on the oscilloscope, we go reverse. Because we're only doing channel A right now, we can put channel B to 0, and make sure to put channel A to AC, not DC. And we could lower the scale a bit so it's easier to read. 100 microseconds per division seems nice, and we can keep it at 5 volts per division. Next we'll take our cursors and we'll move it to the peak to peak. So for cursor 2 to go to next Y max, and the same with cursor 1. So now we have the peak to peak, which is shown under channel A voltage right here. And next what we're going to want to do is measure the period. So we'll set T1 to the beginning of one cycle, which is right here. That's the beginning of the cycle. And then we'll take cursor 2 and set the Y value to 0. Now press OK. And the time shown under T1 to T2 is 497.198 microseconds, and that's the time, the period. And we cannot forget that to do the frequency, it is always the reciprocal of the period, So we know this is around 500 microseconds, which equals to 2 kilohertz. Or this would be, this time right here, 497.198 microseconds, which roughly equals 2 kilohertz, around that range, close enough. And the period and frequency are the same across the voltage source and R2. Next, what we're going to want to do is measure channel B, which is across R2. Across R2. So we'll turn channel A off, set that to 0, and then we'll turn channel B on AC. And we'll do the same thing on channel B, but we'll keep the scale at 100 microseconds, but increase the voltage. Decrease the voltage. So we have a nice, easy to read. And then we'll do the same thing as channel A basically. So what we're going to do is set cursor 1 to the next Y max, which is here. Cursor 2 to the next Y max, which is here. And as you can see, we have our voltage peak to peak right here. Next, what we're going to want to do is measure the period. So we'll set the cursor 1 to 0 at the beginning of the circuit, and cursor 2 to the beginning of the next wave. So go Y value again, set that to 0, and that's the beginning of the wave right there. As you can see, the time is the same, 497.198 microseconds, and the frequency would also be the same too, roughly 500 microseconds right here, which equals to 200 kilohertz. But because this is not approximate, because this is approximate, this would equal roughly around 2 kilohertz. And as I said before, the period and frequency are the same across the voltage source, R2. We can go ahead and X out the oscilloscope because we got our measurements. X that out, and we can also notice that this right here, this voltmeter U1, measures the voltage right here of the whole circuit, and this voltmeter over here measures across R2. So the voltage across R2 is 3.577 volts. Yes. And that's how you create an AC circuit and use measurements using voltmeters and oscilloscopes. Yeah.
Now we're going to set up our AC circuit on the bench. Here is R1, which is 100 kiloohms, and this is R2, which is 56 kiloohms. We're going to connect R1 to our power stripe, and also along the same row here is R2, which we're going to connect to our ground. Then we're going to need to power our circuit, and we're going to do that with the function generator. And in order to set the voltage on our function generator, we're going to connect it to our multimeter.
That should be good. And then when you plot this, essentially you just connect frequencies, which are all these, and your voltage should be here, and it should give you some sort of code just like that. Yeah. The funny thing is
Connect positive to positive, and the negative to negative.
I changed this, but that doesn't make sense.
Turn it all on. We want to set it to AC.
Yeah, I don't
and change the range.
My code doesn't work, I don't know why.
Now from our calculations and from the simulation we did in Multisim, we know that in order to have 10 volts peak to peak, our RMS voltage is going to be right around 3.535. So that's what we're going to set our function generator to. So our digital multimeter is reading the RMS voltage, and then we're just going to adjust the amplitude until we get right around 3.535. And that's pretty close. And then our frequency, we have a 2 kilohertz frequency, which we know is the same as 2000 hertz. Get that adjusted as well. And now we can power up and connect all of our instruments to our circuit. So we're going to put a couple of jumper cables in. So there's a separate place to hook up all of our sensors and our power and ground. Over here. And I'm also going to put some cables in between the resistors, and we're going to use those when we measure R2.
Yeah, that's what we're supposed to use, but
Alright, so we're going to hook up our function generator power. Then we're going to start off with our digital multimeter measuring the RMS across the voltage source, so across the whole circuit here. Then we're going to connect our oscilloscope probes. Our channel 1 oscilloscope probe is going to measure the voltage source. Positive to positive, negative to negative. And our channel 2 oscilloscope probe is going to measure the, well, we're going to measure a couple different things, but we're measuring across R2 with channel 2. So channel 1 across the voltage source, channel 2 across R2. Great. Now everything's connected and we can turn on our oscilloscope. So we already have our RMS voltage across the circuit, right? It's right over here. We figured that out when we calibrated it, and it's roughly about the same once we have everything connected with our resistors. Now we're going to measure the voltage peak to peak using the oscilloscope, and we're going to start with the old school method. For the old school method, we start off with an auto. It gives us kind of a good start in terms of having all the scales where we want them to be. Let's turn this menu off. And to measure across the voltage source, we're going to turn off channel 2, so we just have channel 1 showing. We're going to adjust the horizontal scale so that we can see everything nice and easy. And the horizontal position, so that the top of the sine wave is right along that center bar. And then we adjust the vertical position so that the bottom of the sine wave is right at the bottom of the screen. And that way we can actually count squares to get our peak-to-peak voltage. So I'm counting 1, 2, 3, 4, 5 squares. And in the bottom left corner we can see that each of those squares is 2 volts. So 2 volts times 1, 2, 3, 4, 5.1 squares is about 10.2 volts, which is pretty close to what we would expect. So that seems spot on. Now we're going to measure the period across this voltage source. Adjust the vertical position back up to right around the center here. It's nice because it kind of snaps to the center. And then we change the horizontal position so that the 0 of the sine wave, so the beginning of a period, is right along the left-hand side of the screen. And we can see a full period here. And so we're going to measure from the beginning of the period to the end of the period, once again by counting squares. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. And we can see here that each square is 50 microseconds. So 10 squares times 50 microseconds is 500 microseconds, and that's our period. And to get the frequency, we just do a little bit of math, because the frequency is the reciprocal of the period. So we just divide 1 by our 500 microseconds, and we end up with 2,000 hertz which is 2 kilohertz, which is right around what we measured on the function generator, so that seems about right. So we have measured the RMS voltage, the peak-to-peak voltage, the period, and the frequency on our voltage source. Now we're going to take those same measurements along R2. So the only thing we need to change in terms of wiring here is our multimeter. So we're going to move our multimeter, well, we can do it right over here, and we can just keep the ground where it is. That is just fine. So now we have a new reading over here for our RMS voltage across R2. It's about 1.209 volts.
Don't you love syntax?
And to get the peak-to-peak voltage and the period, and therefore the frequency, we're going to go back to our oscilloscope, and we're going to turn off channel 1, turn on channel 2, and take some readings. Turn off our menu here, make it a little easier to see. Alright, so again we're going to adjust the horizontal position, line up with that center line, adjust the vertical position so that the lowest point of the sine wave is right along the bottom of the screen, and we're going to count squares. 1, 2, 3, 4, 5, 6, 7. We have 7 squares, and each one of those squares we can see is 500 millivolts. So 500 millivolts times 7 squares is 3,500 millivolts, so about 3,500 millivolts, that'll do. Then we're going to get the period by again adjusting the vertical position, so that's right around the center, in a horizontal position so that the 0 of the sine wave, or the beginning of the period, is along the left-hand side of the screen. And we can see right away that it's the same as it was across the voltage source, but we'll count just to show. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares, and each square again is 500 microseconds, 50 microseconds, so we know that the total is 500 microseconds. And then once again we can get the frequency with math by dividing 1 by that 500 microseconds, and we end up again with 2000 hertz or 2 kilohertz. So we have used the old school method to measure the RMS voltage, the peak-to-peak voltage, the period, and the frequency across the voltage source of our circuit that we created, our AC circuit, and also across resistor 2.
Now we're going to do the new school method for finding the voltage peak-to-peak, voltage RMS, time, and the frequency across the voltage source and resistor 2. To do so, we have to select channel 1, which is going to find the voltage source. So we're going to unselect channel 2. And then, to find the voltage peak-to-peak, we're going to click Measure, Voltage, and then scroll down to Voltage peak-to-peak. And it'll display it right there on the oscilloscope, which is 10.2 volts. The next measurement is voltage for RMS. So you're going to click Voltage, scroll down, and select Voltage RMS. And it'll display as well on the oscilloscope. The next measurement is the time. To find the time, you're going to click Time, Period, and select that. And then to see the time, and turn off the menu, and it'll show right there 500 microseconds. The next measurement is the frequency. So we're going to pull back the menu, go down to time, and scroll down to frequency, and select that, and then turn off the menu again to display it. And it'll show right there, it's about 2000 hertz. So now we're going to find it across resistor 2. So to do so, we're going to turn off channel 1 and switch it over to channel 2.
Yeah. Which means you get ultra cheap because you can just XXX in one move. Yeah. So no, but it's okay.
The first measurement is the voltage peak to peak. So to find that, we're going to scroll down to voltage peak to peak after clicking voltage, and then it should display right there in the oscilloscope 3.56 volts. The second measurement is the voltage RMS. To find that, you're going to go down to voltage RMS and then select it, and then it will too display on the oscilloscope, and that is 1.26 volts. The second or third measurement is the time. So you're going to press menu again and then go down to time, click period, turn off the menu again, and then it'll display 504 microseconds. Now the last measurement is the frequency. So we're going to pull up the menu again, go to time, and then scroll down to frequency, and then select that, and close the menu. And then it should display, it's fluctuating between 1.984 kilohertz and 2000. So that's how you find the new school method for across voltage source and across the resistor tube.